Hi, my name is Alex. I am a civil engineer major at Rose-Hulman and a tutor for AskRose, and today we'll be talking about how to complete the square. So for completing the square, the goal is to get an equation in standard form into an equation in vertex form, where in standard form you have an equation that's usually some coefficient, it could be no coefficient, x squared plus x with another coefficient, and then a constant. And so you can convert that into vertex form by completing the square, and we'll show you how to do that here in a moment. So take this equation for example, x squared minus 9x plus 14 equals 0. How do we complete this square? So first you have to identify all of the coefficients, a, b, and c. So in this equation, our a is just 1 because our x squared doesn't have a coefficient given to it. B is negative 9, and c is 14. Next, we divide all of the coefficients by a. Since this is 1, this is a pretty simple example. Next, you want to move c over a to the other side of the equation. What this means is that you are moving the constant on the left side of the equation to the equivalent on the right side of the equation. Next, you complete the square by calculating b halved squared and adding to both sides of the equation. So for this instance, we would be changing our equation to x squared minus 9x plus 14 to x squared minus 9x equals negative 14. And then for step 3, you have to calculate b over 2 squared, and our b is negative 9 over 2 squared, which gives us 9 over 2 squared, which is 81 over 4. That's our b over 2 squared. Now you have to add that to both sides of the equation. So for the left side of the equation, you just have x squared minus 9x plus 81 over 4, which equals the right side of the equation, minus 14 plus 81 over 4. Now, the last thing you have to do is simplify that. Since you have like terms in the equation, 81 over 4, negative 14, and then the 81 over 4, those are all like terms. So if you combine the ones on the right side, and then reorder the equation into vertex form, you will get your completed square form. So now let's jump into some examples. So for this one, our a is 1, our b is minus 18, and our c is 112. All of that equals 0, so we don't have anything else to worry about. So to complete the square, since our a is 1, we don't have to worry about dividing c by our first coefficient. We can go ahead and move that to the other side of the equation. So now we get x squared minus 18x equals negative 112. So next we have to find what b over 2 squared is. So our b here is negative 18 over 2 squared. Well, 18 over 2 being 9, negative 9 squared gives us 81. So that's our b over 2 squared. Add that to both sides of the equation. X squared minus 18x plus 81 equals negative 112 plus 81. Now we have to simplify and rewrite our equation into vertex form. So here, because we have 9 squared, we can rewrite this equation as x minus 9 squared, which equals, if we simplify this side, is 33, I believe. Negative 33. Let me double check that really quickly. Sorry, negative 31. Even civil engineers make mistakes sometimes. Negative 31. So with this being said, we can now rewrite this back into our vertex form, put everything back on the left side, and we have x minus 9 squared, quantity of x minus 9 squared, plus 31 equals 0, and we just completed the square. So let's move on to something a little bit more challenging. For this one, we don't have this equation equals 0. We have it also equal a constant. So we have a couple of extra steps to do because of this. So instead of dividing c over a and then moving c over a to the other side, we can just move this rc over to the other side and subtract from the 22 to get our new equation. So now we have x minus 2 plus 8x equals 20. Simple as that. So now for our b over 2 squared, our b is 8, over 2 is 4, squared is 16. Add to both sides of the equation. We have x squared plus 8x plus 16 equals, right side of our equation, 20 plus 16. To do a little simplifying, since 16 is our new c value for this, we can rewrite our left side as x plus 4 quantity squared equals 36. So just as a quick check, if you don't see how I got from this equation to this equation, let's FOIL out x plus 4 quantity squared to see how that equals the equation that we had in the previous step. So if we FOIL this out, we have x plus 4 times x plus 4. Our first gives us x squared, our outside gives us 4x, our inside gives us 4x, and our last gives us 16. 4x and 4x add to 8x, so this equation is the same as what we had in the previous step. Now if we rewrite our equation that we got here into vertex form, we now get x plus 4 quantity squared minus 36 equals 0. And that's it for our second example. This one is a bit more challenging because instead of our a coefficient being 1, which makes things a little bit easier for us, now we have it as 3. So we actually have to do that step that we said previously. So first we have to divide all of the coefficients, a, b, and c, by a, which gives us, if we divide this by 3, divide this by 3, and divide this by 3, that now gives us x squared plus 4x minus 3 equals 0. If we rewrite that like we were doing before, we get x squared plus 4x equals 3. And now we can finish this equation the same way that we've been doing the other ones. So our b over 2 squared is 4 over 2 squared, which gives us 2 squared, which gives us 4. Add that to both sides of the equation. X squared plus 4x plus 4 equals 3 plus 4. Do some rewriting, just the same thing that we did before. X plus 2 quantity squared minus 7 equals 0. I went ahead and skipped the last step of moving it over so that way you could see the final equation. But this example is important because you're not always going to get a case where you have a be 1 as your coefficient. This simplifies things a lot. Sometimes you're going to have a constant that does not equal 1 that causes you to do that extra step in the beginning. So as a little bit of a more challenging problem, This one also has a coefficient that is not 1, so we have to divide every single coefficient by a. So if we do that really quickly, we get x squared plus this one is going to give me a fraction, so let me rewrite that really quickly. So this one is going to give me, I believe it is 13 over 2x minus 6 equals 0 as our new equation. So now we have a b as a fraction, which might look intimidating, but it's going to be the same process as before. We rewrite this equation just like we did before, moving c to the other side. And we get x squared plus our new b, 13 over 2x, equals 6. So carrying on just like we did before, we have our b over 2 squared, b 13 over 2 halved squared. So because this is a little bit more challenging because it is a fraction, I'll go ahead and show you how 13 over 2 divided by 2 is the same thing as 13 over 2 times 1/2, which gives us 13 over 4. So our new inside is 13 over 4 squared. Let me double check really quickly what 13 squared is and erase this extra. And see that we get 169 over 16 as our new b, or as our b over 2 squared. Add this to both sides of the equation. Equals 6 plus 169 over 16. And this gives us x plus 13 over 4 squared equals 6 plus 169 over 16. So to add this fraction, we're going to have to convert 6 into a fraction as well. So to convert this 6 into a fraction, I'll go over here, we'll multiply 6 by 16 over 16. 6 times 16 is, let me do this in my head real quick, is 96 over 16. 96 plus 169 is 265. So our new equation, the answer to us completing this square, is 13 over 4, x plus 13 over 4 quantity squared equals 265 over 16, or x plus 13 over 4 quantity squared minus 265 over 16 equals 0. As a little bit of a more challenging problem, we have a negative a coefficient that is also not -1. So in order to do this one, it's actually a little bit simpler than it looks. So for this one, excuse me, we just want to go ahead and move everything to the right side to make this quantity positive. So to do that, we have 0 equals -3 minus 5 plus 2x plus 3x squared. Rewrite this equation into standard form and combine some like terms. We get 3x squared plus 2x minus 8 equals 0. And now we have our equation in standard form. We can go ahead and divide all of the coefficients by 3, which gives us our equation of x squared plus 2/3 x equals 8/3. And here in this step, I went ahead and moved the 8 over to the other side, made it positive, and divided by 3, which gives us 8/3. Now we have to find our b/2 squared, which in this case we have 2/3 divided by 2 squared, which gives us 4/36, or 1/9. So add that to both sides of the equation. This gives us x squared plus 2/3x plus 1/9 equals 8/3 plus 1/9. Rewriting this equation into vertex form gives us x plus 1/3 quantity squared equals 8/3 plus 1/9. And so instead of the previous example where we had a fraction being added to a constant, now we have two unlike fractions being added. But we can make these have common denominators by multiplying 8/3 by 3/3 to give us 24/9 to have a common denominator as 1/9. Add those together, we get 25/9 for a final equation of x plus 1/3 quantity squared minus 25/9 equals 0. And that is the end of the different examples that we have. And so now we're going to do the Desmos.
Yep.
So now we're going to show how some of these can be solved on Desmos so that we don't have to do all of them by hand.
So just pull it up on our. They're not sitting yet. It's just here.
If I pull up Desmos really quickly, you can see how, let's take one of the equations from our previous examples. Let's start with the first one, x squared minus 18x plus 112. So if we do x squared, so minus 18x equals 0. Yes, okay. So let's zoom out on this graph, see where it takes us. I'm not seeing it, unfortunately.
That's really high. I have to just scroll up to like.
Yeah, me zooming out is doing nothing for this. I'm not sure why.
Let's go from vertex form to that form then, maybe?
Yeah, okay, so let's look at this equation in the vertex form that we solved for instead. So we have x minus 9 squared plus 31 equals 0.
Actually, it probably should be y equals 0.
Ah, yes, you're right.
That's probably the problem. There it is.
Yes, okay. So with this, you can see how the vertex of our graph, and let's turn this one off so you know that we're only looking at our first equation. Our first equation is marked in red, and it has a vertex at x equals 9, y equals 31. So if you know anything about how to graph parabolas, you know that a parabola centered at the origin has the equation of y equals x squared. And so to adjust this equation, you can alter where it starts on the x-axis, shifting it right horizontally by subtracting 9 from the x squared value. So now instead of x squared, we have x minus 9 quantity squared. We can also add 31 to that to move our starting point for the y's. And as you can see, our equation here in vertex form is the same as our original equation. The difference in standard form and the vertex form is that standard form has everything added together in different unlike terms. Vertex form has it so that way you can see exactly where the vertex of your graph is, and for us that is at the point 931. Looking at our other example, x squared plus 8 minus 20, we can see a similar thing. X squared plus 8x minus 20. Make sure I'm getting that right. Yes, okay. So here we have a parabola with its vertex at minus 4, minus 36. The form that we had for this one was x minus 4 quantity squared minus 36. Sorry, x plus 4 quantity squared. And as you can see, that's the same as our original equation, except this time in vertex form, we can see immediately where the vertex should be. Desmos graphs us our equation in standard form, but using vertex form, you could graph this parabola yourself by plotting the vertex at -4 and -36, and then plugging in different numbers and then extrapolating from there where should the rest of the curve be. And by extrapolation, I just mean you can assume where the parabola is going to go by only looking at a couple of points. So if you look at, oh wow, if you look at this point right here, -36, if you plug in -3 into the equation, for example, -3 is your x. In a regular parabola, the next value is 1 over and 1 up. So because this is a regular parabola that has its vertex at a different point, we can see that our next point over will be 1 over and 1 up. And for us, instead of 0 going to 1, it's from negative 36 going to negative 35. So if you plot the vertex, plot a second point, and plot a third point at the mirrored position of the second point, that'll give you the tip of the curve. And from there, you should be able to graph the rest of the parabola. So just reviewing really quick. In order to get from our standard form into the vertex form, you have to follow these 4 steps. You have to start by identifying all of the coefficients, a, b, and c. If your a is not 1, divide all of the coefficients by a and move c over a to the other side of the equation. Once you've done that, calculate b over 2 squared and add that to both sides of the equation. After that, it's just a matter of rewriting your equation, putting everything back into the left side of the equation, and then you end with vertex form, and that's how you complete the square. If there are no more questions, I know that there is a chat feature available for everyone to ask any questions that they have. Then we are going to go ahead and end the stream here. I hope you enjoyed the stream and maybe learned a little something.